And good evening, everyone. I'm Lakshit from class 8. I'm going to say something about satellites and explain you. First, in the first session, we learned about orbits. Orbits are the imaginary path in which a heavenly body or an artificial satellite moves on. There are many types of orbits. Some of them are listed like geostationary orbit, a orbit where the satellite and the planet both move in the same position in same exact time. Distance between the planet and the satellite is 36,000 kilometer. Second is the polar orbit which is connected to both poles, GSO and polar. Types of orbits. There are highly elliptical orbit, uh, highly elliptical orbit, then it's a equatorial orbit. The orbit is which is above the equator is known as the equatorial orbit. Then is the polar orbit that connects North Pole and South Pole. Uh, that is known as polar orbit. Then is inclined orbit, uh, which an orbit which has a slight bit of inclination. Then is the circular orbit. All the points of the satellite at about the same altitude. Then is the elliptical orbit, which is also known as highly elliptical orbit. Then, then is the highly elliptical orbit. Elliptical. There are many shapes of the orbit, such as HEO. It's highly elliptical orbit that is not in a circular. We have seen orbits in a circular path, but in the highly elliptical orbits are in the curved way, making unusual shapes. Then is low Earth orbit which is situated in the lower portion of Earth or known as the southern hemisphere. Then is the medium Earth orbit. Uh, it's situated at the equator or the equatorial region of Earth. Then is geostationary orbit. Rotation of Earth and revolution of the satellite are in the same time and same position, which is known as the geostationary orbit. When geostationary orbit is also in a circular path, the rotation and revolution both when happens in the same time in the same area in an artificial satellite, it is known as a geostationary orbit. How does a satellite stay in orbit? A satellite stays in the orbit due to the high velocity and the presented gravity, which creates the resultant force. Any object, if crossed 11 km per second, will escape the Earth's gravity. You have the velocity of the at least the velocity of the vehicle you're in has to cross 11 km per second to escape the Earth's gravity. Then is the parts of the satellite. In a satellite, it's not only the detectors and everything. The satellite has tons of metals around it called as the bus, which uh, which helps to protect from other sources in the solar system. A satellite needs to be launched with help of a rocket. It cannot escape the velocity of the gravitational force of Earth, which is 11 kilometers per second. So, I'll mention some of the satellite parts. Satellite has many parts such as solar arrays, thermal blanket battery, bus structure. The structure of the metals in it is known as the bus structure. Star trackers, reaction, star trackers, reaction wheels, transmitter receiver, high gain antennas. Uh, it it has many processors, omni ultras, and flight computer. Uh, I made a satellite which was also given by the course itself. Uh, it has a highly metal bus which protects the inside coverings of the satellite. First, here in this satellite they are given. I built it, and the microcontroller used in the satellite was ESP32. Uh, if you don't know, a microcontroller is actually microcontroller is actually a combination of many parts such as a chip, microcontroller chip, a USB port, and many voltage sensors. And microcontroller also contains a CPU. The microcontroller here, which is used, is ESP32, and then comes the solar panels, which are mounted on the bus. Uh, the whole solar panels work on solar panels will get the energy from the solar energy. Solar panel will get the solar energy and withdraw it uh, and use it as an electronic to charge up the negative and positive electrons to work this satellite. Then there are mainly three sensors in it, such as uh, the LDR sensor, which contains four pins: AO, DO, GND, and VCC. VCC pin is for negative, and AO pin and GND pin is for positive. LDR sensor. It has to be. All these sensors are mounted on the breadboard, which is a small breadboard, and this satellite also has a battery, which can also be used for charging. And this the satellite contains two more sensors, which are DHT11, containing three pins: VCC, data, and GND. And the last sensor, which is in this satellite of StudentSat, is BMP 180, which contained four pins: VCC, GND, SCL, and CDA. Uh, this microcontroller used in the StudentSat is VLSI, and this is ESP32 circuit. Uh, there are two main pins here, which is one is VCC positive and GND, which is negative. We have to careful while mounting the sensors in the breadboard, because of the pins in it. It can it can malfunction if not used properly. we had given to study connectors and breadboards. Connectors had two parts, which are the male and female. The anode, which is positive, and the cathode, which is negative. We have to mount the anode into the cathode to work the sensors properly. There is the wires that would be used to connect all the sensors and batteries to the breadboard is jumper wires, and the circuit is mainly in three ways. First is voltage, next is current, and resistance. There is a formula for currents. Voltage is equal to current into resistance, and uh, current is equal to voltage divided by resistance, and resistance is equal to voltage divided by current. To perform properly in a circuit, you have to mount properly in the breadboards or in the given circuits uh, to you. If we want to you on a LED bulb, which that needs some wires, uh, an LED bulb, a battery, and some and a switch. Uh, you off on switch. To operate a single small operation like this also needs particular devices and uh, particular wires to operate on. Sensors. Sensors are electrical components which help us understand the physical properties like atmospheric pressure, light intensity, etc. To understand them in detail. This satellite allows us to get the light intensity, the temperature, and the humidity of your surroundings. The satellite would be launched. If it would be launched, it cannot be launched without a rocket. It has to be it has to go with a rocket. Then in a particular orbit, the rocket will detach and place the satellite in its particular orbit, which gravity would uh, it would orbit the earth. The gravity and velocity would create a resultant force uh, for the satellite to orbit on. With this, I'm ending to explain, and this was a really tough challenge for me to build the satellite and to explain. Thank you and have a nice day.